morning all. My name is Simpi Ugoi. I am from Sipsar College, Sarsagar, Physics Department, 4th semester. And in this pandemic, hope you all are well in your home. So, today I am going to discuss about the most fascinating natural phenomenon, that is light. So, before I start, can you tell me one thing? What light actually is? Is it particle or wave? Well, let's discuss about this topic with some scientific explanations and proofs. If we see the history, in ancient times some Greek philosophers, including Plato and Pythagoras, thought that light originated in our eyes and that vision happened when little invisible probes were sent to gather the information about faraway objects. But Arab scientist Alhazen figured out this as wrong. And then Johannes Kepler gives the revelation in this field. They got confused what light actually is. Is it wave or is it particle? Then, for the first time, René Descartes represented a wave theory of light which introduced the light as a disturbance. Although Pierre was the first scientist to believe the particle nature of light, and it is further developed by Isaac Newton. Robert Hooke and Christian Huygens, they are the most famous scientists who believe the wave theory of light. After them, the double-slit experiments of Thomas Young saw the wave nature of light through his interference patterns, and Max Planck also worked in this field. So Isaac Newton told that light has particles using his corpuscle experiment, but this can explain only the refraction and like this kind of phenomenon. But other phenomena couldn't be explained by this experiment. Not all phenomena could be explained by Newton's law or Newton's corpuscle theory. So here let us see another experiment. Let us see beam A and beam B of light, that they cross their paths, they do not interact with each other, they just passed. But if light was the particle, it couldn't be happen, and the particle got scattered in random directions. Let us see the photoelectric effect. Here we can find two proofs: the quantity of energy in one hand and the photon or the particle nature of light in the other hand. But here also problem become when the double-slit experiments of Thomas Young conclude the wave nature of light through his interference patterns simultaneously must be the particle too, to explain the photoelectric effect which gives the diffraction. Later, Einstein concluded that a packet of energy with zero is mass of photon, and explain both the double slit experiments and the photoelectric effect. And here we can see that in this video I am presenting a few proof of wave particle duality in natural phenomenon which can be easily visible. So if we see light as a photon, then its motion will be traverse on or helical directions and has three-dimensional motion, and it has projectile motion too. And on the other hand, it has rotational motion. It behaves like a wave. So we can say light is a particle that traverses like a wave. So like lights, there are so many natural phenomena where we can see the duality in matters. So there is, and they are developed another physical field, that is quantum mechanics. Let us see the mathematical derivation of this duality of wave equation. Let us see. According to de Broglie hypothesis, both light and matter have the dual character as wave and as a particle. When electron is taken as a wave, then it has wavelength and it has interference patterns, etc. Here we are trying to evaluate Let us see here. If nu is the frequency of this wave and E is the energy, then we can take that energy as Planck's equation, that is E is equals to h nu. Here h is the Planck's constant and nu is the frequency of the wave that we had taken. Let us mark this as equation 1. If we take again electron as a particle, then we had this energy using the Einstein's equation E is equals to mc square. Here m is the mass of the particle or the mass of the electron, and c is the, mark this as a equation 2. Here m is equals to, it is, I told that. Let us combine both equation 1 and equation 2. Here we can see that mc is equals to here we can see that h nu is equals to mc square, and here we take mc is equals to h nu by c, and here we know that nu by c is equals to 1 by lambda, and here lambda is the wavelength, and so we can further write that mc is equals to h by lambda. So here we got Planck's constant h in the denominator, and here in terms of momentum we got mc is equals to h by nu, h by lambda. So let us take as equation 3. Here we explained de Broglie equation in terms of momentum, that is p is equals to m into c, here where m is the mass of the electron and c is the velocity of light and h is the Planck's constant and lambda is the wavelength. So this is the de Broglie wave equation. Let us see another explanation of this duality. Here the general time-dependent Schrödinger equation is the most strongest and most developed equation to explain the duality. There are two equations, time-dependent and independent. So here, let's see the importance. In this time limit, we all are grateful for those respected scientists who sacrifices their life in search of origin and gives us so many facts and introduce ourselves to the reality. Thank you for having me.